Good morning friends. Topic for today's class is time, speed and distance. This topic includes time, speed, distance, downstream, upstream, average speed, relative speed, circular race, number of points are involved. We take all the things one by one with some examples so that you can easily understand this concept. Now when we start with this topic, the basic formula in this topic is, you all know that distance traveled, you can say that the distance is always equal to speed into time. That's our basic formula. The distance traveled is always equal to speed into time. When we consider the distance, that is either measured into kilometers, meters. When you consider the time, this is measured into hours or seconds. When you talk about the speed, generally either in kilometer per hour or this is given as meter per second. When we measure the speed, either given in kilometer per hour or meter per second. Now the first point here is how to convert your speed from kilometer per hour to meter per second. Suppose speed of a person is given 72 km per hour and you have to convert into meter per second. We know that this 72 km per hour means 72 km upon 1 hour. Now I want to convert this into the meter per second. It means kilometer has to be converted into meters and hour has to be converted into seconds. So I can say 1 kilometer has 1000 meters and 1 hour has 3600 seconds. Means for converting my speed into kilometer per hour to meter per second, first thing is I have to convert my kilometer into meter and hours into seconds. So I can say 72 into 1000 upon 3600. Now this will be cancelled out. 2, 5, 2, 18. So I can say 72 into 5 upon 18, which is equal to 22 meter per second. So what we inferred here, this is a standard fraction 5 upon 18. Means when speed is given into kilometer per hour and you have to convert into meter per second, multiply your speed 5 upon 18 and your speed is converted into meter per second. On the other hand, when speed is given into meter per second, you have to convert into kilometer per hour, multiply this by 18 by 5 and your speed is converted into kilometer per hour. So this is the first step that you have to cram. When speed is given into kilometer per hour, you can multiply it by 5 by 18. This will automatically be converted into meter per second. Similarly, when speed is given into meter per second, you have to multiply this 18 by 5 and this will be converted into kilometer per hour. Suppose I say speed of a person is given as 20 meter per second. Speed of a person is given as 20 meter per second and we have to convert this into kilometer per hour. So we know it very well. 20 into 18 upon 5. 5 will go on 4. Our speed would be taken as 72 km per hour. So this is the first thing that we understood here, that is how to convert a speed from kilometer per hour to meter per second and from meter per second to kilometer per hour. Now after this, we have this formula distance equal to speed into time. We try to understand the relationship between distance, speed and time. Distance is directly proportional with speed. Distance is directly proportional with speed when time is constant. Similarly, distance is directly proportional with time where speed is constant, and speed and time, they are inversely proportional. So we can say the relation between speed and time is inversely proportional. What do you mean by this? In the same time, if your speed is more, it means the distance traveled by you will be more. If the distance traveled by you is same, so you can say when speed is more, your time taken will be less, right? So we can say speed and time, they are said to be inversely proportional. Now there is a need to understand this concept into the question format. That simply means the things which are directly proportional, their ratios are same. Suppose we know that distance and speed are directly proportional, right? If I say ratio of speeds of three persons ABC is 1:2:3. There are three persons ABC and the ratio of their speed is 1:2:3. We have to find out what is the ratio of their distance, that we have to find. In the same time, we know that speed and distance both are directly proportional. When ratio of the speed is 1:2:3, so we can say the ratio of the distance will also be 1:2:3. Your ratio would be the same. On the other hand, if the question is in such a way, ratio of speed of three persons ABC is 1:2:3. We have to find what is the ratio of their time taken. There are three persons ABC and the ratio of their speed is 1:2:3. We have to find out, in order to travel the same distance, what will be the ratio of their time taken. Now we know that speed and time, they are inversely proportional. That means when the ratio of the speed is given and we have to find the ratio of their time, you have to make it reverse. It becomes as 1/1 is to 1/2 is to 1/3. LCM is 6, so we can say 6:3:2. That becomes your answer. So when we have to find ratio of their time taken, so we can say the ratio of their time taken is 6:3:2. Right? We cannot make it as 3:2:1, that will be wrong. That could only happen when there are only two persons. Suppose if I say only two persons are there, A and B, and the ratio of their speed is given, that is 2:3. We have to find ratio of their time taken, we can make it as 3:2. Means when ratio of their speed is given 2:3 and we have to find ratio of their time taken, we take it as 3:2. How we have made it? Because I can say speed is inversely with time, it becomes 1/2:1/3. That automatically would be 3:2. I think the point is clear. This concept is used in solving some sort of questions. Means in a statement where speed ratio is given and we have to find the ratio of the time, it could be easily found. If ratio of speed is given, in the same time we have to find ratio of the distance, that would easily be taken. Now we use these concepts in solving our questions. Some standard sort of questions are there. Start with one by one. First type is, while going 4/5 of the speed, a man reaches 25 minutes late. Question is, while going at 4/5 of the speed, a man reaches 25 minutes late. We have to find out what is initial time taken by the man to travel the distance. What is initial time taken by the man to travel the distance? Means if its speed is not decreased, what should be the time taken by the man in order to travel the distance? Now we have two approaches for answering this question. The first we'll solve with the help of our equation approach. and second I also tell you how to go with the ratio approach. Suppose speed of the person is s, original speed is s, and at s speed time taken is equal to t, right? Now as per to the given condition, s into t is equal to a distance travelled. Now it is given that if he goes at 4 by 5th of the speed, means speed of the person is 4 by 5s. Now he is going at a speed of 4 by 5th, means he is going at a 4 by 5s, and he is late by 25 minutes. It means he has taken 25 minutes more. Again, this speed into time is the distance. If he goes at 4 by 5 of the speed, we can say the speed would be 4 by 5s, and he is late by 25 minutes. So time taken by the person will be t plus 25. Now we have to solve it and find the value of t. That s will be cancelled out. I will multiply 5t equal to 4t plus 100, or I can say t is equal to 100. That becomes my answer. Pay attention again what I have done. Suppose speed of the person is t and time taken is t. S into t is equal to distance travelled. Now if he goes at 4 by 5th of the speed, it means he is going at 4 by 5th of the speed, and he is 25 minutes late. Time taken by the person would be t plus 25. Now it's a very simple equation. I have to solve it and find the value of t. Right? This is our first approach. The same question can be solved with the help of the ratio approach. How we can go for it? It is given that while going at 4 by 5th of the speed, suppose original, we will try to find the ratio of their speed to original to new. Original speed to new speed. Let us assume original speed is 1, new speed becomes 4 by 5. The ratio is 5:4. That is with original speed to new speed. I know that the ratio of the time taken is reversed. That becomes 4:5. What I have stated, while going at 4 by 5th of the speed, it means if I say initial speed is 1, after changing the speed it becomes 4 by 5. I can say the ratio of the speed will be 5:4. Now after this, if speed ratio is 5:4, then ratio of the time is 4:5. Now I can say at the original speed he has taken 4x time, at the new speed he will take 5x time. And as per to the question, it is given that he is 25 minutes late. It means how much is late now is the difference. X is equal to 25. We have to find the initial time taken, means at the original speed 4x, that is 4 into 25. Your answer is equal to 100. That becomes your answer. Pay attention here what I have done. This approach is taken as the ratio approach. We have taken that the person goes at 4 by 5th of the speed. If initial speed is 1, he goes at 4 by 5th. It means the ratio of the speed will be 5:4, and we can say the ratio of the time would be 4:5. It means that is 4x, that will be 5x. The difference is x, that is equal to 25. So I can say the original speed time taken by the person is 4 into 25, 100. Second question on the similar line, if speed of a person increases by 20%, he reaches 15 minutes early. What is the initial time taken by the person to travel the distance? If speed of a person increases by 20%, he reaches 15 minutes early. We have to find out what is the initial time taken by the person to travel the distance. If I go with the equation method, what I will do? Let us assume speed s and time is equal to t. S into t is the distance. He increases his speed by 20%. It means his speed would be s into 120 by 100. When you increase your speed by 20%, you can say the mean speed will be s into 120 upon 100. And he reaches 15 minutes early. It means time taken by him is 15 minutes less, t minus 15. I have to find the value of t. We can just solve it. S will be cancelled out. 26, 25. I can say 5t is equal to 6t minus 90 and t is equal to 90. So we can say initial time taken by the person is equal to 90 minutes. Same question may be answered with this ratio approach also. How we can go for this? Speed of a person increases by 20%. It means if initially it will at 1, now it becomes 6 by 5. Because that have to be increased by 20%. So we can say the ratio of their speed is 5:6. Now we can say ratio of their time taken, that will be 6:5. He reaches 15 minutes early. It means he has taken 15 minutes less. The difference is of 1. The 1 is equal to 15. We have to find the initial one, that is your original 6. 6 is equal to 19. The answer is the same, that is equal to 90. Pay attention here what we have done. Suppose the speed of the person is 1. His speed increases by 20%. So I can say this is 1. Now it has become 6 by 5. Ratio of their speed is 5:6. We can say the ratio of their time will be 6:5. In this case, he reaches 15 minutes early. So I can say the difference is equal to 1. When we say 1 is 15, we have to find the initial one. 6 will be equal to 90. Our answer is set to be 90. Third very important statement about this. If a man goes at a speed of 20 km per hour, he reaches 15 minutes late. But if he goes at a speed of 15 km per hour, he reaches, or I can say if he goes at a speed of 25 km per hour, he reaches 10 minutes early. Right? What we have to find out? We have to find out the distance that man is traveling. What should be the optimum time taken by the man in order to reach in time, and what speed he should maintain so that he reaches in time. Means 3 questions we have to find out. The first one is, if man goes at a speed of 20, he reaches 15 minutes late. If he goes at a speed of 25, he reaches 10 minutes early. We have to find the distance, optimum time and speed that he reaches in time. Now, for answering this question, you have 2 approaches. The first approach is very simple equation approach. Here, the speed is already given. So we can say let us speed of the person is 20 and time taken by the person is t minutes. In this case, he is late by 15 minutes. It means he has taken 15 minutes more. I have added t plus 15. I have assumed it into the minutes and my speed is given into kilometer per hour. So I can say 20 into t plus 15 upon 60. In the second case, but if he goes at a speed of 25, he reaches 10 minutes early. That means 25 t minus 10 upon 60. Because in that case, he would be 10 minutes early, means time taken by him would be 10 minutes less. Now I can find t here. This would be cancelled out. 5, 4, 5, 5. 4t plus 60 equal to 5t minus 50. T would be equal to 110. So I can say the optimum time would be taken by the person would be 110 minutes. That is the answer to this question. Because t is the optimum time when he will be there in time. So here I can say t will be equal to 110 minutes. Now I have to also find the distance also. This is the distance and this is also the distance. In both equation at any place I can put t equal to 110. If you have to find the distance, so I can say the distance is equal to 20 into 110 plus 15 upon 60. 20 will go on 3 and I can say the distance is 120 upon 3 kilometer. That becomes the distance. Pay attention here. We have to find the distance traveled. From this equation I have found the time. Right? Time is equal to 110. Right? Now we will put this 110 inside this. We will solve it. And we can say the distance is equal to 125 upon 3. Now we have to find their speed. So we can say the distance travelled is 125 upon 3 upon their required time. Time is 110 minutes. Speed I have to find in kilometer per hour. We convert into hours. 110 upon 60. This would be taken as 125 by 3 into 60 upon 110. This would be cancelled out. 3 will go over 2. We can say 250 upon 11 kilometer per hour. That is the required speed of the person he maintains so that he reaches in time. Pay attention here. The 3 type of questions may be asked over this. If he is asking the distance, first we find the time, then we can go for the distance, and if you have to find the speed, we can find in such a way. Now there are some standard shortcuts here. If we have to only find the time, if the question is we have to only find the time, that may also be found in such a way. Initially speed was 20, now speed become 25. So we can say ratio of their speed is 4:5. Initially their speed was 20, now speed is 25, so we can say ratio of their speed is 4:5. Here I can say ratio of their time is 5:4. If speed ratio is 4:5, so we can say ratio of their time is 5:4. Now in the first case he reaches 15 minutes late. In the second case he reaches 10 minutes early. So we try to find the difference in their time taken. In the first instance he reaches 15 minutes late. In the second instance he reaches 10 minutes early. Here I can say the difference between their timing would be 25 minutes. Because first you are late, now you are early. Right? Now we can say the difference in their time is 25 minutes. Here the difference is 1. So 1 is equal to 25, so we can say 5 will be equal to 125. Means when the speed of the person was 20, he has taken 125 minutes. In that case, he was 15 minutes late. It means his time taken should be 110 minutes. That is the required answer. Pay attention here what I have done. It is given that speed of the person was 20 and after that he changes to 25. Here I can say the ratio of their speed is 4:5. And I know that time is inversely proportional with speed, so we can say the ratio of their time will be 5:4. Now it is given that in the first instance he was 15 minutes late, in the second instance he was 10 minutes early. The difference between these two is 25. Here the difference is equal to 1, so I can say 1 is equal to 25. We have to find this 5, so I can say 5 would be taken as 125. But this 5 is associated with the speed 20, and we know that when the speed was 20, he reaches 15 minutes late. It means when he had taken 125 minutes, that is 15 more than the initial one. So I subtract 15, my time would be 110 minutes. I think it's clear. Similarly, if we have to only find the distance, in this question if we have to only find the distance, so we may have one more approach by which we can directly find the distance. Suppose the distance travelled is equal to x. Suppose total distance that has to be travelled, this is equal to x. Right? In the first case he is going at a speed of 20. It means he is taken time would be x by 20. In the second case he is going at a speed of 25. It should be x upon 25. In the first case, speed of the person is 20, so we can say time taken by the person is x upon 20. In the second case, speed of the person is 25, time taken would be x upon 25. Now we can say that when speed is less, time taken will be more. We try to find the difference will be in their time. Here he was 15 minutes late, here he is 10 minutes early. Same case we consider, means the difference in their timing would be 25 minutes. So I can say just subtract and this equals to 25 minutes. We divide it by 60. Why we have done this? Because speed is given into kilometer per hour and the 25 is the minutes. So we convert into the hours. Now solve it. LCM would be 100. 5x minus 4x equal to 25 upon 60. X upon 100 equal to 25 upon 60. X is equal to 25 into 100 upon 60. 5, 12, 5, 5, 4, 3, 4, 25. We can say that distance is equal to 125 upon 3 kilometer. That becomes your answer. The same distance we have found when we have solved this question with our earlier method. This may be very helpful when you have to only find the distance. You don't need to think. There is no need to think anything. What you have to simply think. Take the distance is x. First speed is 20 x by 20. Second case speed is 25 x by 25. In the first case I am late by 15 minutes. Second case early by 10 minutes. It means the difference in their timing is 25. So I can say x upon 20 minus x upon 25 is equal to 25 upon 60. Just solve it and your answer is there. 125 upon 3 kilometers. That becomes your answer. I hope the concept is clear. So this is an introduction to our topic time, speed and distance, in which we have learnt just how to use the concept of time, speed. Our formula is distance is equal to speed into time. We just learnt how to use this concept. Here I would like to discuss one very standard question. Without stoppages, a train travels 50 km in an hour. With stoppages, it travels 40 km in 1 hour. We have to find out what is stoppage time in minutes per hour. Means how much minute he will take stoppage in an hour. Now when I have to answer this question, what I can say, if no stoppage is taken in 1 hour, he travels 50 kilometers. If stoppage is taken, he travels 40 kilometers. That means he travels 10 kilometers less. Means if no stoppage is taken, he travels 50 kilometers. If stoppage is taken, he travels 40 kilometers. So we can say that he travels 10 kilometers less if stoppage is taken. Right? Means for how many minutes it took stoppage, that is the time taken by him to travel this distance of 10 kilometers. Means time taken, if you have to find the stoppage time, so what we can say, for finding out the stoppage time, we have to find the time taken by the person to travel this 10 kilometers, right? His actual speed is 50, so we can say, in order to travel this 10 kilometer, time taken by the person is 10 upon 50 hours, or we can say 1 upon 5. We will convert into minutes, that is 12 minutes. So we can say in 1 hour, stoppage time of the person is equal to 12 minutes. So our answer is he takes a stoppage of 12 minutes per hour. That becomes our